In this video, you will learn about trig word problems. You will be able to read and interpret real-life problems from context. There's going to be a story to it, and use trig functions, sine, cosine, tangent, and the inverses to find missing sides and or angles. Before we dive into the problems, let's look at certain definitions. One of them is the angle of elevation. If you look at the bottom right here, I'm circling a camera. The camera is pointing forward, pretend it's at the ground level. This would be the line of sight. Now, if instead of taking a picture of the bottom of the tree, you want to take a picture of the top of the tree, you would have to raise or change the angle of the camera. So now the camera would be looking up, and you would have to raise the angle this much so that you start looking at the top of the tree. That would be the angle of elevation. How much you have to elevate or raise the camera in order for you to be able to look at the top of the tree instead of at the bottom of the tree. We also have the angle of depression. Now in this example, we're looking at this person. He's at the top of the tower. His line of sight is always horizontal, so he's looking forward. Now, if instead of looking forward, he wants to look at this guy on the boat, he would have to lower his line of sight by angle X, which is right here, in order to be able to see that person. That lowering is called the angle of depression. Okay, now we will be doing problem number one. Problem number one, we have a story. There's a nursery that plants a new tree. There's a picture, and attaches a wire to support the tree while its root take hold. Hopefully you've seen in real life when you walk around, there's trees that have a wire attached. Notice the wire is not attached to the top of the tree, it's attached to the trunk. And there's a stake in the ground so that the wire stays put and it doesn't get loose, otherwise they wouldn't serve its purpose. Okay, let's keep reading. They tell us that there's an 8-foot wire. I'm going to label that wire as 8 feet. And it is attached to the stake on the ground. From the stake on the ground, we have an angle of elevation. So angle of elevation means we are going to be raising the line of sight. That means it's going to be right here at the bottom. They tell us that that angle of elevation is 42 degrees. 42 degrees. I'm getting the number from right there. Then they are asking us, find to the nearest tenth of a foot the height of the connection point on the tree. They're not talking about the height of the tree. They're talking about the height from the ground to the connection point. So that means how much is this height? That would be X. Which I'm going to put here so that it looks like a triangle. So now, in this case, the angle of reference is 42. Across from that is the opposite side. X is the opposite. We also have a 90-degree angle. The tree is upright, so it forms a 90-degree angle with the ground. Across from that is the hypotenuse, which is 8 feet. That's the wire. And we also have the adjacent, which in this problem we will not use, but I'm still able. So opposite and hypotenuse, that would mean sine of the angle of reference, which is 42, equals, opposite is X over hypotenuse is 8. We will be using the cross multiplying technique. 1 times X is X. 8 times sine 42 is 8 sine 42. X is equal to 8 times sine 42 is 0.6691. When I multiply them, I get 5.3528. However, they want us to round to the nearest tenth of a foot, so I'm going to cut it off at 5.4 feet.